Notice how aluminum replaces iron, and iron is left out by itself, and aluminum is mixed with another thing. In the second type of example, notice how you have the nonmetal come in and replace the other nonmetal to make another compound, and then the other nonmetal is left by itself. To determine if a single replacement reaction will take place, you must use something that we call in chemistry called the reactivity series. Metals are arranged in order of how reactive they are. Metals high in the reactive series can displace metals lower down. However, metals lower on the reactivity series cannot displace metals higher up. Here's an example. Potassium, sodium, and calcium are all really high. Silver, gold, and platinum are really low. So anytime these metals try to replace metals up here, does not happen. But metals down here can replace anything below it. Taking a look here, here's an example of a single replacement reaction, where we take copper wire and we react it with silver nitrate. The reaction is that copper, since it's higher up on the reactivity series, replaces the silver. And all this stuff right here is all silver metal attaching itself onto that metal wire. This copper solution is now made up of copper nitrate. So all this is silver. Okay? Now, another thing that you need to understand is also the halogens. And the halogens are also arranged in order of most reactive to least reactive. At the top of the list you have fluorine. On the bottom part of the list you have iodine. Okay? Here's the most reactive, here's the least reactive. These guys cannot replace above, but these guys can replace anything below it. So taking a look here, iodine cannot replace bromine because bromine's higher on the list, so therefore no reaction happens. However, fluorine can come in and replace iodine because it's higher on the list, and therefore you will get this as a reaction. Single replacement reactions are also called oxidation reduction reactions, and we shorten that to call redox. Redox reactions usually involve metals and nonmetals, or two nonmetals where oxygen is either a reactant or product. The driving force in these reactions is the transfer of